your attention. Thank you, John, for letting me talk about statistical programming and data science. It's one of the things that I love very much. Let's see. So we're going to talk about Reticulate and how to use R and Python together in a really nice way. Like John said, you can use all sorts of languages with R. So the Reticulate package makes this really easy from the RStudio IDE. So let's get started. So just a moment about me. I'm very happy to take part in the R community in any way. I'm a PhD student at Claremont Graduate University, and I'm fortunate to be a part of some labs that have been in the area of biostatistics and neurocognitive sciences. My latest research, we're talking about indoor air pollution and cognitive function, which is really interesting and important. I really enjoy using R, Python, Julia, and other languages for data science. So I want to take a moment and just take a moment and look back at last year. I got to attend a few of these meetups, and there were just a few things that I want to kind of remind you of if you didn't pick them up yourself. So the R community just seems really, really friendly. I'm really happy to come here and meet with all of you. We're made up of academics, entrepreneurs, students, analysts, all sorts of professionals, and some of you are more than one, which is absolutely amazing. Last year, one of the things that I thought was really cool, there was a visualization competition, and someone who may be here, instead of putting time on the x-axis, they represented it with color, which I thought was really, really awesome. John had a lecture on unit testing with the TestStat package, and we saw that TensorFlow is great from R and Python and does a whole lot more than deep learning. We saw that dplyr is a great package for data manipulation. It has a nice syntax. We can pipe our commands in together. But then Datatable has advantages of speed. More recently, Hadley came out the dtplyr package, which allows us to kind of use the syntax of dplyr and get some of the speed from Datatable. TidyText is a great package for common NLP tasks. We saw that. And some of the secret sauce in machine learning comes from hyperparameter tuning. So searching hyperparameter space to really hone in and tune our machine learning models for our applications. There's a few other things that I wanted to mention, but we'll just go through them. So with regards to why would we use R and Python together, you might have a partner that has a function they made in Python, and you want to use it in RStudio. So Reticulate helps with that. You might find that your research collaborator have a research collaborator that has data that aggregated for you in Python, and you want to visualize it in ggplot. We can do that with Reticulate. You might have a statistician on your team who put together some data in SPSS, for instance, and had a .sav file, and you want to bring that into R, and you might even want to deploy that into Python. So how might we work across each of these points where we're connecting different languages together? You might prefer zero indexing Panda frames, and you want to pass them to R to use some of the cool descriptive functions there. Let's see. So I wanted to touch on a few different tweets about the Reticulate package and about using R and Python together that I thought kind of speak to what we're talking about here today. Why would you want to do this? This person's Medium article talks about what it came down to is they really wanted to use a powerful function from Python in their R workflow. This person is talking about that they really like the dictionaries in Python, and that they work in R. Let's see. I like this tweet because this author, she's kind of speaking to having a little bit of difficulty in getting this all set up. She may need to she's talking about she needed to kind of uninstall Conda, reinstall it, put it together, kind of doing the things that it took for her to get it to work. It wasn't just smooth sailing, but if this feels like it, if this is how it feels for you, don't be discouraged. Great data scientists run into these sort of problems as well. With Reticulate, we can use all sorts of different approaches to doing regression and predictive modeling. So we can do that in R, we can do that in Python, we can do it in Julia too. Here's a tweet that someone's talking about. They're about to teach about 100 students to use Reticulate, and they're a little bit nervous. So, hopefully, if you feel nervous, if you're not so sure about your install, we're going to get you installed. We're going to get you set up so you can start to use Python in the RStudio environment. And this one really sums it up. There's one, basically the tool we're doing here, one single and powerful IDE, RStudio, for two powerful programs, R and Python. So let's start with something more familiar. You're installing packages, installing and loading packages in R, which we do all the time. But you could run into some problems. You might be working with a new R user who is used to having a lot of these routines programmed or installed at default as a default in their statistical programming system, so they're not really sure how to use packages and what it means to install them. Let's see, there might be conflicts between the packages that you and your collaborators are using, so this is something that you can run into. So we're going to start with something familiar. This is one way that I like to do it. If you're familiar with the Pacman package already, great. If you're not, this kind of helps us skip a few steps here. So what the pload function here is doing, it's first checking to see if it can load these packages that are inside this function. If they're not available, it seeks to install them automatically. Once it installs them, it loads them. So now if we jump over to using Reticulate, we're going to load the Reticulate library, and we're going to specify where the version of Python we want to use lives, and we're going to feed that path into the use Python function. After we do that, we're going to check to make sure that it's available to be used, and we're going to pass true to the initialize argument. Here we're going to initialize basically start Python if it's not already ready for us. We can do something similar for Python modules. So if we want to make sure that this is all from RStudio, we want to make sure that Python modules like pandas are available. We're going to pass that name inside our PyModule available function, and it's going to tell us if that Python module is available. Here's another way to look at kind of how you're set up if you use the py_config function. We're going to get a little bit more output here, including additional. If you have more than one install of Python, maybe you have multiple versions for different purposes, it will tell us that here. Okay, so now we may be ready to use Python in RStudio. So some of the things that you want to think about, especially if you're familiar with R but you're not so familiar with Python yet, is how to access objects and how to access the contents of objects. So in R, we do that with the $sign operator here. As you can see, to get to the date column in df_weather, we use the $sign. So in a similar way, we can do something similar with Python, but instead of using the $sign, we're going to use the dot. So you're familiar with loading libraries, loading packages in RStudio. We do something similar in Python. So we call it, we use the import function here. So you put import and then model name. The example of that would be import pandas to import that library. You can also import pandas using the alias. So you'd say import pandas as PD. Another way that Reticulate allows us to import packages for use in RStudio is to use the import function from the Reticulate package. Here we're basically we're importing pandas into an object that we're calling PD, and then from an R code chunk in the RStudio IDE, we can access functions from the pandas package using the $sign operator on PD. Here's another look at that. Okay, so let's take a few minutes and get set up. Hopefully, if you have any questions about what we just talked about, let's talk amongst each other to make sure that we all have Python ready to go from the RStudio IDE. Let's give it a try. All right, let's get back. Hopefully, Reticulate is working for you in RStudio. If not, hopefully we'll figure it out by the end of the night. Let's see what we can do with it. One of the things you can do with Reticulate is source Python scripts in R. So let's say that you or a buddy or a colleague made a function in Python, and it's ready for you to use, but you want to use it from the RStudio IDE. You can do that with Reticulate. So here's a simple function that we made using Python. So we called it makeGuac. This is the makeGuac function because we're going to be first reading data that is on avocados, and then we're going to choose the type column, and we only want observations, we only want rows that indicate organic avocados. Next, it's going to select a few specific columns by name, and then we're going to return that data file. So with Reticulate, we can access that Python function using the source_Python function. There we pass the name of that Python function as a character string there.
How do we get the avocado CSV file?
It is on my GitHub page. So if you go to GitHub with my name, Michael Espero, last name is Espero, the data will be in that in the OC rug Reticulate repository.
It's also in the OC rug.
Oh, it's also, I'm sorry, it's also in the OC rug repository now. So that's how, this is that function in action here, where you're just reading in the avocado data, but taking advantage of the other few commands that we have in that function, makeGuac, and then we can see the top or the head of that avocado data file there. And it looks like we have.
Can we pass in a URL to get that avocado file and pull it off there, or do we have to?
Yes, it's from Kaggle, so you can pass a URL for it.
There you go. So just copy the URL to that.
So we wind up with a data file with only the organic avocados and the columns that we specified in the function. Now let's confirm translation from R to Python. We want to make sure that the objects that we may be familiar with in R are turning out the same way that we would expect them to be in Python, and we want to take note of maybe some important differences there, particularly if we're not especially comfortable with Python yet. So now we're going to use a data frame from Kaggle again. This one is tweets. It's tweets on the subject of wisdom. So we begin by reading in the tweets.csv file, and here's an R chunk doing that using the read_csv file from the tidyverse. And we're going to take a glimpse of it, which is a nice tidyverse function that allows us to see the dimensions of that data frame, along with column names and some of the values in those columns. So let's take a peek at the tweet content column, and let's look at the first row. So we do that by using the $ operator after our data object, and we're indicating that first row there in square brackets. So we see the output for this tweet seems to be about unresolved thoughts. So we can this is the one keep this in mind, because we're going to take a look at this same row, the same row of this same column from Python. Another look at that from R, still in the R chunk. We're using the pipe and the select function to select the author name in the tweet, because we want to see the text from the tweet again, but we also want to see the name of the person who tweeted it. Looks like his name's involved. So So we were working with the df_r object that contains our tweets, and now we're going to make it available to the Python chunk in our R Markdown file. We can do that with Reticulate using the r_to_py function. There we're just feeding in that R data frame, it's a tibble, and we're assigning it to the name df_py. Take a moment to see how we are loading a few modules in a Python chunk. Here we're loading the NumPy, we're using aliases, and we're loading the NumPy module, pandas, and natural language toolkit. All right, so now we're in a Python chunk, still from the RStudio IDE. So in this R Markdown file, we're indicating that in this chunk, it's not R code, it's Python code. If that hasn't come across yet, you indicate that in the curly brackets in the top left of the R Markdown code chunk to make it a Python chunk. So here in Python, we're accessing actually that same data object that we were working with before in an R chunk. The way that we do that is going to R dot. And then the df_py, the one that we use the conversion to, is available using the R dot. And to get the dimensions of that data object, we're using shape. Looks about the same as before. And then we can go using columns after that dot from our data object. We're going to see that we have those same column names. Now here's one of the important differences. If we're not comfortable with Python yet, it's important to note that Python is a zero indexing language. So to get that same row, to make sure that we're looking at the same thing that we just saw in the first row of the R data frame, that tibble, we're going to indicate the 0th row here for the author name and for the tweet content, and it looks like the same thing. So even though we're indexing a bit different here in Python, we're still looking at the first row in the data frame. It's the same author and the same content with regards to the tweet content column. Back in an R chunk, we can actually still access the Python pandas data frame here. As you can see, this is that df_py data object that we made earlier with that conversion function. And we can see that we can output that. This is in an R code chunk, but using the pandas data frame. Let's take a peek and see how many unique authors are in this collection of tweets that we have here. So we go unique, and we're going to pipe the length function to it with regards to the author name from our data frame. And we see that there are about 2,700 unique authors in this data file. Let's take the top 5 authors in terms of likes, and let's assign it to a new data object. And we're going to call it df_r_top5. So this object will contain the rows of the authors who have the most likes, the top 5. I like this tweet, so this speaks to what we're going to do next. I think it's like a moment of humility when you see someone like Hadley Wickham saying, even he can't do something. So we're going to make a little plot next, and we're going to try to save room. You might run into this when you're plotting yourself, especially if you have a lot of labels in the x-axis that are oriented horizontally. This is going to, so in this exercise, we're going to make those labels turn to a 45-degree angle. It's kind of funny. Hadley says even he can't do that on the first time without looking it up. So here is the ggplot code. We're back in an R chunk, and we're using the data frame that we just made. So we have a data frame that contains the top 5 tweet authors in terms of likes. And with ggplot, we're indicating what we want in terms of the variable on the x-axis. And then on the y-axis, we have the author on the x-axis, the number of likes on the y-axis. We're going to make a bar chart, and we're going to indicate a few different, just 2 labels, as you see there. We're going to let the theme_tufty function take care of some of the styling. We get that from the ggthemes package. And And then with regards to angling those x-axis labels in the way that we want, we're going to use the element text function. As you can see there, for the angle argument, we're indicating 45. So that's going to allow us to fit our column names. Not as much of a big deal in this instance, but especially if you have a lot of labels on your x-axis, depending on your application, this is a helpful little tip. And there it goes, a simple bar chart, and we see that our x-axis labels are rotated to the 45-degree angle. Let's see, what about sorting data in the tidyverse? We're still in the R chunk here. We're using all of our tweets here from the df_r data frame, and we're going to pipe over the arrange function and indicate that we want our data to be descending in order of likes. So at the top of our data frame, we'll have observations that have the most likes, and at the bottom of this data frame, it will have the fewest. Jumping to something else, we're still in, let's see, with this one, we're still in our chunk. We're going to go back to the avocado data, moving from the tweets to the avocado data, taking a glimpse of it like we did before. And let's do a few other steps. So we're going to take the clean names function from the janitor package. The reason that you might like to do that is because, let's say you get a data frame that hasn't been all cleaned up nice and standardized for you. What this function will do automatically is bring all of the column names to lowercase, and if there are any spaces in them, anything like that, anything irregular, it will insert underscores between those spaces. So you have nice and regular column names. And as we can see here, when we do names on the guac data frame, everything's lowercase, and we have underscores where our spaces used to be. You might notice here another thing, especially if you're still considering kind of the differences between R and Python or some of the similarities. You might see here that we have an equals operator, equal sign, rather than the arrow operator that we're used to using in R. We're still in our R chunk here. The equals assignment operator is that's what you often see in Python, but it works the same in R. So I don't know if it helps you to kind of have something that is consistent between the two languages. You can go with that equal sign instead of the arrow. Now we're going to take something, well, before we go into this plot, when we read in the data about the avocados, we saw that the type column was a character vector, but it'll be more useful to us if we make it a factor. So we're going to factor that variable and assign it back to itself. And then in the lubridate package, we're going to use one nifty function that allows us to work with time a little bit easier. So in this ggplot function, the one thing I want to direct your attention to is that we are wrapping the date variable on the x-axis with the week function from the lubridate package. And this way, it's going to automatically parse it up in a way that the x-axis will be by week. There are similar functions that do this by month, by year. Oh, and so with this particular plot that we'll see, we are using geom jitter, so we're going to make a point plot. We don't want a lot of overlap in our points, so the jitter gives a little bit of noise in there so that the points don't overlap as much. And we're adding the geom smooth function, and we're selecting the least squares method for this approach. So we'll be finding that line that minimizes the sum of square deviations. Some of the square deviations from it. And there it is. Back in Python, we can do something similar. So now in our R Markdown chunk, or actually in our R Markdown file, we are indicating that this here is a Python chunk. So remember, if that's not clear yet, in the Python chunk in your R Markdown file, you're going to indicate that it's a Python chunk rather than an R chunk in the top left corner in those square brackets. So we'll take a function from the Seaborn package to make a regression line here, which is a little bit off the screen. Can't make it small. But it turns out to be a similar plot with a similar message. that basically shows that the cost of the average price for avocados is going up over time. So we can do that in Python, or should we do that in R, and we do that in Python. Let's go.
We got it. So what did we do? We
All right.
sourced it.
We ready for the last section? Hopefully. Okay. So you may have heard RStudio talking about using R and Python as a love story, which is, I'm not sure I'm curious what you think about that. It's kind of great to think about using the best of both of these languages to express yourself, and to do so, in a way that's enjoyable. Hopefully it feels that way for you so far with Reticulate. So here we're going to import some of the contents of the NLTK Python module, which is the natural language processing toolkit.
Can you check your microphone?
Oh, I'm sorry. So we're using the some of the contents of the natural language toolkit here. We're importing that, and in this module, there's a bunch of built-in data. We're going to look at a little bit that speaks to the R and Python love story, a little bit. What we're going to use is text8. So text8 is the name of the built-in data in NLTK that refers to a collection of personal ads. So people seeking a mate. And one of the functions in NLTK is the concordance function. So if we add that with a dot between the data object and that command concordance, we can use that function, feeding in a word that we want to see. We basically want to see the context of this word love in. So we're going to look through this collection of personal ads to see the context that the word love is, wherever it's present within this within these personal ads, and it will show us. So below you can see that we have people that they love romantic and they love drives. Let's see, love my 2 kids. It says kids okay, as I love family. So we can get a sense of the context of love in this data set here. Go ahead and choose a few different words that might be interesting if you want to kind of peruse through these personal ads yourself.
Concordance is case insensitive?
Good question. I don't know that for sure. I'll get back to you on that. Or you
It
can
looks
try.
like it there because you got all kinds of different cases.
Yeah. And I would say in the natural language, in many natural language processing workflows, you might bring it into lowercase as you're processing that data before you start to search for things like this, for instance, or modeling. We can use another function from the NLTK module. This time we're going to look for similar words, and similar here means like it's used, how it appear. We're looking for the word meet, and we want to see words that appear in similar contexts. So a few of these make sense: relationship, share, beginning, meeting, find, very. Australian, I'm not so sure, but with regards to this group of personal ads, it seems to appear in similar contexts. So you can give that a try a few different words. There's the dispersion plot function, which allows us to pass in a vector of words here. So we're looking for the word love, the word looking, the word fun, the word true, things related to perhaps personal ads, and we're seeing how these words are distributed amongst this corpus, this collection of documents. So I want to kind of summarize, what we're doing here, hopefully what it's seemed like so far. Once we get everything set up, the bridge is already there for us to use. We're getting objects from R to Python, objects from Python to R. It helps to know what to expect on the other side. So, for instance, when we were looking at what's in the first row of an R data frame, and then looking at what's in the 0th row of a Python data frame, we can confirm that those are the same things, and we are then aware that Python is a 0 indexing language. We won't run into that little hiccup. It's really about making those connections work, and hopefully they work for you so far. Once it is working for you, you have both R and Python at your fingertips in the RStudio IDE, hopefully to make anything that you wish. If you haven't learned anything, hopefully I've convinced you that there are many resources available, such as RStudio. If you go to their website, there's a ton of information about Reticulate and using Python and R together. Let's see, there are videos out there of other individuals presenting on using R and Python together using Reticulate. You might want to check out. And there are plenty of blog posts too, using all sorts of, for all sorts of applications, building web applications using Reticulate, whether that's with Shiny or something else, deploying models, whatever you can think of, you probably can do it with this sort of a setup. So I encourage you to look at additional resources and continue to improve your comfort. If you don't feel so comfortable yet, improve your comfort with using Reticulate for your own purposes. And however you use R and Python, I hope it brings you access to more tools and more collaboration.